Good day, ladies and gentlemen. Our presentation today is analysis of programming languages for artificial intelligence. This project has been done for the subject programming language and design concepts for the third year, first semester of the Sri Lanka Institute of Information Technology. These are our group members, and this is the agenda. We'll be giving a short introduction, then the beginning of AI, the branches of AI, programming languages used to develop AI, a demo of a AI program, and the future of AI. Okay, what is artificial intelligence? Artificial intelligence is based on the assumption that process of a human thought can be mechanized. That is, AI is an exciting new effort to make computers think, machines with mind in the full and literal sense. It can be defined as systems that can act rationally and also systems that can think like humans. History of AI. In the 1940s and 50s, a handful of scientists from a variety of fields such as mathematics, psychology, engineering, economics, and political science began to discuss the possibility of creating an artificial brain. The field of artificial intelligence research was founded as an academic discipline in 1956. The Turing's test. In the 1950s, Alan Turing published a landmark paper in which he speculated about the possibility of creating machines with true intelligence. He noted that intelligence is difficult to define and devised his famous Turing's test. If a machine could carry out a conversation that was indistinguishable from a conversation with a human being, then the machine would be called intelligent. This simplified version of the problem allowed Turing to argue convincingly that a thinking machine was at least plausible, and the paper answered all the most common objections to the proposition. The Turing's test was the first serious proposal in the philosophy of artificial intelligence. The Dartmouth Conference, 1956. In 1956, the Dartmouth Conference was a moment that AI gained its name, its mission, its first success, and its major players, and is widely considered the birth of AI. The Golden Era. The years after the Dartmouth Conference were an era of discovery, of sprinting across new grounds. The programs that were developed during this time were to most people simply astonishing. Computers were solving algebra word problems, problem solving in geometry, and learning to speak English. AI winter. In the 70s, AI was subject to critics and financial setbacks. AI researchers had failed to appreciate the difficulty of the problems they faced. Their tremendous optimism had raised expectations impossibly high, and when the promised result never failed to materialize, fundings for AI disappeared. The year 1980 to 1987 can be considered the boom for AI, that is, the rise of expert systems. An expert system is a program that answers questions or solves problems about a specific domain of knowledge, using logical rules that are derived from the knowledge of experts. The knowledge revolution. The power of expert systems came from the expert knowledge they contained. They were part of the new direction in AI research that had been gaining ground throughout the 70s. 1987 to 1993 is the second AI winter. The business community's fascination with AI rose and fell in the 80s in the classic pattern of an economic bubble. The collapse was in the perception of AI by government agencies and investors. 1995 marked the invention of Mercury, which is an important language which is used to develop AI applications and would be discussed further. 1997 was the year in which the Deep Blue system was implemented, and that is the first chess playing system. The branches of AI. Algorithms originally developed by AI researchers began to appear as parts of larger systems. AI had solved a lot of very difficult problems, and their solutions proved to be useful throughout the technology industry, such as data mining, industrial robotics, logistics, speech recognition, banking software, medical diagnosis, and Google search engine. Therefore, AI branched out as follows: robotics, neural networks, genetic programming, image recognition, GMEDEF, expert systems, vision systems, logistics planning, and autonomous systems. Listed below are some of the languages specifically designed to develop AI applications, that is Lisp, Prolog, Mercury, and Apollo. You should note that general purpose languages such as Java, C, C++, Python, and Perl can also be used for AI development. Let's talk about Lisp. Lisp was specified in 1958, and Lisp is the second oldest high-level programming language in widespread use today. Only Fortran is older. Today, the most widely known general-purpose Lisp dialects are Common Lisp and Scheme. Lisp pioneered many ideas in computer science, including tree data structure, automatic storage management, dynamic typing, object-oriented programming, and self-hosted hosting compiler. The name Lisp derives from list processing language. Linked lists are one of Lisp languages. Major data structures and Lisp storage code is itself made up of lists. As a result, Lisp programs can manipulate source code as a data structure, giving rise to the macro systems that allow programmers to create new syntax or even new domain-specific programming languages embedded in Lisp. Let's talk about Scheme. Scheme is known as a pure functional language. That is, it uses only functions, and it is very different to normal procedural programming language. Lisp Scheme is a dialect of Lisp, and functions are referentially transparent. That means it has no side effects. Side effects is a problem which have been faced by procedural languages, but a functional language such as Scheme does not have this disadvantage. Functions are used using lambda calculus. Here we explain an example of a Scheme function where you define a function called factorial n, where it takes the argument n and returns a factorial answer. This is known as the base case. If n is equal to 0, it would return 1, and it recursively calls factorial n minus 1, and finally once it comes to the base case, it would return number 1 and return the factorial of n. Here it's important to note that there is no looping structure or looping construct in Scheme, and only recursion is used for multiple operations.